This is Dr. T.H. Culhane from the University of South Florida teaching the Food Energy Water Nexus class. And I want to point out why we didn't take a really hot shower today. Some people will say, well, because it's winter and it's cold in winter, but that's not the reason, because it doesn't matter how cold it is outside if the solar panels are insulated with a glass, or in this case plexiglass clear, you call it window, so to speak, and is really good and black, because it isn't the heat of the sun that makes a solar hot water system heat water. It's the light of the sun. As long as the sun is shining on a clear day like today, even if the weather outside is really cold, that light, like going through space, encounters a greenhouse effect when it comes in and hits the black surface. And then when it turns into infrared radiation from visible light radiation, those longer wavelengths of light cannot escape through glass or plastic. Glass or plastic acts, in fact, as a greenhouse. That's why we use them in greenhouses, and blocks the infrared waves from coming out. So it traps the heat in, and when it hits a black surface and transforms into infrared radiation, it then spreads that heat through the black metal into the copper pipes, and then into the water therein, and then goes up into the tank, which is then insulated and holds that heat. So I was wondering, as I was taking a shower just now, why was it not more than, say, 30, 32 degrees Celsius when it should have been over the temperature of my skin? It should have been about 40. Naturally, when we were working in Egypt, these would get up to 50 degrees Celsius by the end of the day, and then in the morning there'd be a 10-degree loss, and it would go down to about 40. The next morning you'd take a shower, it'd be about 40, but still enough to make it feel really hot. Here, we're at the end of the day, it should be piping hot, but it's not, and that's because there's a lot of dust on here that's reflecting the light back, and then there's a lot of dust that got in that is keeping the light from being absorbed as heat, because there's no longer black there. So right now we can't take these panels off and clean the dust on the inside, but we can certainly make this as clear as possible, and then we will have hopefully a nice hot shower by the end of tomorrow. We'll just have to deal with the temperature of the water in the morning that's already found in here because of this. But for all those of you who are using solar hot water, there's a myth going around in the winter time that solar doesn't work in the winter and it works perfectly well in the summer. Well, of course, in the summer it's so hot that everything is heated up. There's no losses at all. Here we're going to get some losses because there's an opening here. This is not completely sealed, so some heat is going to escape from there. This is not the most insulated box here, so there's going to be some losses, but it should work very well in the winter if it was perfectly black. And you can see here it's even white. It's gone white over here and here and here in these spots. There's certainly blockage there from the dust on top. It's a maintenance issue. The inside should be repainted about every year, and the outside every day should be dusted off, just like people dust off the windows of their cars and make them nice and clean. We really need some kind of window wipers, if you like, here. So we're going to clean this off and hopefully during the week have much hotter showers. So welcome to the West Bank, and we hope that you'll all go solar and create true solar cities. Thanks.